All right, the recording and the transcript seems to be on. My screen, I'm assuming everybody's seeing it. I'm sharing it, right? So good spot since
Yeah, we
Amin
see
did
it.
ask about it. So, okay, great. All right. So our topic today is migrating Tableau to Power BI and how we did it back with Fabric. So while this is came about on how we moved to Power BI and Fabric from Tableau at Salad and Go, this really could be used anywhere. There's not going to be a ton of specific things about Tableau. The message that I would say that should come through is if you're going to move from Tableau or anything to Power BI, you got to put in the work. And this is kind of showing how we put in the work and what we did and how we did it from there. Um, how Fernando, for your question, how long does it take to be able to see the recording on YouTube? The answer is it depends. It depends on what my schedule is and how soon I download it and upload it and publish it. I usually try to do it the following weekend, but if things get crazy, it takes a little bit longer. So it's all manual. All right. So again, a little bit about myself. I put my LinkedIn profile into the chat. I'm also on X, formerly Twitter, at Kev Arnold. But I'm finding myself more active on Reddit, which is Kev Arnold 972. So if you want to connect with me there is a very active Microsoft Fabric subreddit. There's also one on Power BI. I don't tend to get on the one for Power BI as much as I do Fabric. And the company that I'm working with here on this one is Salad and Go. And I'll introduce Salad and Go here a little bit. A little bit about myself too. I'm a Microsoft Most Valuable Professional in the data platform area. So that means I work a lot with Power BI and Fabric, a little bit with SQL Server. And, I go out, do these type of talks and let Microsoft know and promote Microsoft products because of it. It's got a long agenda here today. So these are the things I'm going to try to touch on or go in deep. So, there's a lot to go through. I have been able to do this presentation in an hour. The first time I gave it, I think it was about 2 hours that I was able to do it in an hour because I got cut off. The last time I think it was closer to an hour and a half. It all depends on how much questions and conversations y'all want to have during the presentation. So if you want to put something in the chat, I will see it. Or if you want to raise your hand and come off and ask a question, have a little bit of a conversation, um, and we'll be able to have that conversation for as long as possible. So I'm hoping that we'll stay within an hour to an hour and a half. And if we're going long, just kind of let me know. Uh, but you kind of read all this. That I have a slide for each one of these things, if not multiple slides underneath it. So. Okay, let's first kind of go into Salad and Go themselves. Salad and Go, you could see their mission up here. They're a little bit over 12 years old. Around their 10th anniversary, they were really looking at the data and analytics that they needed and started looking into ways to improve their data and analytics. And that's kind of was what came about for this project. We're currently we well not currently we are based in the Dallas Fort Worth area. That was just a last couple of years that they moved their headquarters from Phoenix over to Dallas. So we have locations here in Texas. We have a lot of stores in Dallas, Arizona. They were founded in Arizona, so a lot of the stores exist in Arizona. They've got a very strong following in Arizona. Oklahoma and the Nevada area. I think there's two stores around Las Vegas. They're a very charitable group. They donate out a lot of salads. They've recently hit a landmark or a milestone of 1 million salads donated to charities. They also have internal charities that we could contribute to help out their team members that are at the stores and everything and across the organization. as well as getting 501(c)s that they donate to the local communities. So it's a very good company. I hope you've had a chance to try out some of their salads. Um, they fall into the quick serve restaurant area, which means that they only really have drive-throughs. We don't have sit-down locations. And when you go up to the drive-through, you there's a certain amount of time. We'll talk about this in the metrics coming up. And when you order online, they got a little bit more time, but it's very quick service. If if you've tried Salad and Go and liked it or not liked it or whatever, put a comment in the chat. I'd like to hear if anybody's got any opinions on the food at Salad and Go. They serve a lot of drinks as well. Their lemonade is something that a lot of people love and a lot of new lemonades. And we've also recently come out with a chips and hummus side that people are really loving. We're hearing a lot of good things about that. So. All right, so we were talking about they were looking at their BI layout, and so they set up some goals, right? And this is kind of what I was alluding to, right? Is when they have somebody come up at the drive-through, they have 4 minutes to complete the order, from the time that they place the order at the menu to the time they go through the window and it's presented to them. The target is 4 minutes. It's 8 minutes if you order online, and then by the time you show up. So we have to have our goals in the BI area as well. Thanks for sharing. I'm glad you like the see a comment in the chat that they like the salads and it's great value. It is a great value. That's one of their core concepts is keep it as a great value for the price point that you pay and the food that you get. All right, so some, the things that are on here, right, is first thing they wanted to do was start standardizing on vendors. They were using a lot of different vendors, and really as a company starts and grows within their first year, I've seen this in a lot of smaller companies, or as they grow, they just start using everything underneath the sun, and then all of a sudden they start realizing that they have things that are duplicated. Um, that's certainly the case here with Power BI. Although Power BI hasn't really been used until we came in with this project inside the company, they had E5 licenses. So they have the ability to use Power BI, but we're using Tableau. And it started saying, well, why am I paying for both? Um, the process, they wanted to really clean up the process, improve the performance. We'll talk about some of the performance improvements that have come out of the architecture that we put in, but it has been significant. And our ability to fix anything that's up in production rather quickly has improved with the process that we put into play and the migration that we've made. Um, so that led to having better accuracy, and as I mentioned, the maintainability, and also being able to hot fix it or correct things if we had to really, really quickly. So some of the first steps that we took to get there, right, which is critical in anything that you do, is gain leadership support. So we're going to talk a little bit about how we moved to a medallion architecture, and this was explained to our leadership team prior to really buying into the whole project that we put together and the timeline. So we really got into details, to explain it to the CEO and their senior leadership on what is a medallion architecture, why the process that we were using was going to be better than the process that's currently being used. Well, I think was a very important step. And it was something that they did prior to me joining them. Um, Part of it was because I worked closely with some of the team that's in place before, and we had discussions about that at other places and reasons why doing it and stuff. So then from there we had to build out the team. There was a team already in place. Some of those people decided to stay with the new direction. Some of them decided not to stay, which opened up opportunities to build out the team or open up critical positions that wasn't even on the team. So there was a skill assessment done, what was needed, and that's one of the reasons that I was brought in as an architect, the data architect on the project. And then one of the first couple things that I did was conduct proof of concepts up in Fabric. We started up a Fabric trial capacity. I produced within a couple weeks 3 different proof of concepts so we could look at how we're doing this medallion architecture that we talked about and pitched um, in the best way that we were actually going to implement it. And then had reviews done across the team and explained things on the team to make the choices that you're going to see in the upcoming slides on how we got to this point. But I think that's very important for people to do these proof of concepts and to do it as close to real life as possible. One of the biggest things that we looked at in the proof of concept wasn't even how the reports came out at the end. It was what did our process and development patterns need to look like in order to support doing the deployments, doing our code reviews, and have everything tied together and know every single change that ever goes into our from a report to the semantic model to the data engineering. We track every single change, and I'll talk a little bit about how we do that. But that those proof of concepts establish those patterns um, at the process as well as some of the code patterns that are put into play today. And our code patterns have obviously evolve as we learn more things, but it established it for the first time. All right, so what we looked at was the existing architecture. And when we look over this existing architecture, it actually looks like a pretty good architecture. Um, and so we could see on the far right side is where all the Tableau reports go, and they could get into Excel. Um, and then how they get there from left to right feels like, almost it could almost be talked about as a medallion architecture. And I think this is a very common architecture people use, not only for Tableau, but for other things, but for Tableau in particular, because what we have here is in this area of the SQL database is where all of the work occurs for the Tableau reports to pull in their one big data table. And so this is where we started seeing things to be a problem because this SQL database um, kept growing and growing and growing. And if you know anything about SQL databases, we used what's called an elastic pool. And we had to keep upping the elastic pool to get the data sets that Tableau likes. Tableau loves one big table. So all the work was really done within the SQL Server views or tables that were put together in this area that I have highlighted. And again, that got to be hours that things would run in order to put the data together. So we looked through all the data sources that were coming in over here and identified 22 data sources. So out of those 22 data sources, there's about 80 some odd reports that needed to be moved over eventually. But out of that, we identified, I think it was, I think I have it on my notes here. Yes. Out of the 22 data sources that we bring in, 9 of them provided 82% of the elements that we need on our reports. So we focused on those 9 data sources coming into Fabric first. So this was a wonderful evaluation to figure out what it is that we needed to do. And as we kind of look through, you see there are many different things that are thrown into the architecture here. We got Azure Data Factory. We got Databricks. Got Data Factory again. What's not even on here is there's a ton of logic apps. And this may be what that's trying to represent is logic apps rather than event hubs. But you can see they had a mixture of technology. And that mixture of technology, even though it was implemented on Azure, the Azure portal, there was a lot of things that had to be plumbed together, put together. As we've talked about Fabric, if you've heard anything about it, being software as a service, a lot we could have these type of things available to us, but we don't have to keep adding new services, plumbing things together, networking them together in the background. And that's a lot of what was going on here. In fact, they say that they were using Azure Databricks, and as we dug into it, It really was only when they wanted to run Python code, they implemented it into an Azure Databricks environment, but they weren't using anything like the Azure Data Catalog or the Unity catalog or anything like that. Everything was kind of being used ad hoc. So it really, it was supposed to be kind of put together this way. The challenges that they had was the team switched over so many times. Originally, the team that was put together came from the business, and they did a great job of trying to understand the analytics that they want, but they weren't really data engineers. They weren't really in the IT space, so they just kind of hobbled everything together at the best that they could. And that produced a lot of different challenges. Those challenges then resulted in what we see down at the bottom, the challenges and opportunities of inconsistent availability times. So they have a report, and you're going to see a blurred out version of it coming up here that is called their daily sales report. And this company still likes to have everything emailed out to them, and that's a challenge that we're still fighting through. But that's okay. We met them where they were. We said we're going to email stuff out. Well, their emailed report would sometimes go out at 8 in the morning, 9 in the morning, 10 in the morning, 2 in the afternoon, depending on how long it took to get through this whole process. And this process for that sales report alone could take anywhere from 2 to 4 hours, depending on what was going on. It was always at least 2 hours. So if it happened to fail, the offshore team that was monitoring it would see it. They'd have to restart something. But now you got another 2 hours. Usually it was things like I said, the pool within the SQL Server, it outgrew it, or other stuff was going on all at the same time, and it came to be a nightmare. The other thing that was happening is because, again, in this same area here, these all of these data sets were being built for reports, and not all the reports were trying to share a common data set. So logic that was needed was put into multiple data sets multiple times. They tried to sometimes build the table into the back end and use that into those multiple data sets. But then they would say, I'm going to change that, say, for daily sales. And X number of months later, it would change for some other report. And people were assuming that that logic was changed in all those reports all at one time. But they really couldn't do it that way because they were building too many things out. The example that I always give is we look at how we do our comparable sales. So how we compare stores between last year and this year. And in order for a day to be included in their comparable sales, the day that we're using for comparison must have $300 worth of sales, $300 or more. And the day, say we're going back a year ago, that day a year ago must also have had $300 or more of sales. This way, it took out things that caused outliers. For example, a store a year ago had a power outage. Well, we don't want to include it in the year over year comparison because then it would throw it off, right? So we have business rules in place to handle that. This business rule was put into on the Tableau side multiple data sets because again we're feeding one big data set to probably one report and have to produce that same thing multiple times. So it took a long time to put in that business rule. We have that business rule encapsulated in our new architecture in one place. So if they ever decide to change it and say, well, now we want it to be $500 or whatever it is, or $100, we have one place changes it, all reports pick it up. It's a wonderful thing. The other thing when I came in to the team and was just trying to listen in quite a bit, a lot of the things that they have here are not within source control, and changes could not be tracked. They didn't know when something changed or why something changed. Um, and at the same time, the word workaround was used quite a bit. So it's like let's do this. Here we have this architecture. Oh, wait, we have this problem. Let's work around it by doing this. And so the architecture wasn't totally followed. So that's some of the things that we were seeing from the very beginning. Not all of it was Tableau's fault, but Tableau, from what I hear from a lot of other people, right? Because of Tableau wanting these one big data sets, a lot of people run into these same type of problems. I've talked with other people since I've been presenting this out, and they tell me about very similar problems that they're having. And since Tableau likes one big data set or one big table and Power BI doesn't, we did not want to buy into the fact that we were just going to take the data sets that Tableau uses and point Power BI to it. I've heard people trying to do that and then start digging into it, and they've run into more problems with that. Again, I think I mentioned this at the beginning. If you're going to make the switch to Power BI from Tableau, you're really best off trying to get back to the right type of data set, the semantic model done the right way in order to get the most out of your Power BI reports. All right, so I've talked about Fabric a couple times. I wanted to make sure that we have introduced what Fabric is. So again, Fabric is Microsoft's unified data platform for the era of AI. It's a software as a service platform, which means all of these things that you see here, back to my zooming, everything that you see here is available on the service. So if you wanted to use all of, each one of these things, and like we talked about is over in the other environment, we used multiple things, but you had to set up a new service every time. We could decide to use Data Factory in one set of workspaces, but not use it in another set of workspaces. And we don't have any new data set or Data Factory instances to set up. Databases is the new SQL databases that they have, analytics, industry solutions, but everything sits in Fabric on one lake. One lake is the key. So if I ask you, how many one lakes does any tenant have in for Fabric? The answer should always be one lake. There's only one lake for your Fabric tenant, no matter what. This is key because over here we start seeing, get rid of that, come back here, these workloads that are done within Fabric. And so what these workloads end up having in common is they end up having their data come down. That's the wrong one that I don't want to use. Their data comes down, say through T-SQL into the warehouse, and it's stored on one lake. Or if you're doing data engineering through Spark, the data that it produces is stored over in one lake. The same thing with real-time analytics into a Custo database. And also you could do that with analysis services. All of it, everything is part of one lake, which means you could share that data across the items within your workspace, also outside of your workspace. So, you could have one copy of the data that you could share everywhere because it's all in the one lake. So I think that that's very important. Um, you could set up, you have serverless compute. So that's where our CUs come into play. CUs are compute units, and that's what you're trying to manage cost on. So one of the things in a fabric architecture that you're always looking at is not only how am I architecting, how I'm putting my individual components together, but how you end up looking at managing your CUs in order to make sure you're not spending too many and have to move up in the fabric capacities. One of my most unpopular opinions is one way to control that is to never use Dataflow Gen 2. So they are a hog in CUs, and you won't see there's no, as you'll see as I present more and more decisions that we made, this is definitely one that I push, is we do not use Dataflow Gen 2 anywhere in our enterprise solution. And I think it's important to kind of point that out is what we're going to get into is our part of the enterprise solution. Now, as we start onboarding our departments and we go to other type of things and we share data with them and they want to enhance it or do something else with it, they may end up using something like data flows Gen 2. But at the same time, we'll probably move them off onto their own capacity so that if they do anything that they want and they blow up their capacity, they blow up their capacity. We do things to protect our own capacity. And we'll talk about that, I think, in another slide or two that's coming up. Again, if there's any questions on any of this, feel free. I'm seeing a couple comments in there. Yes, Donald, but Power Query, I am not a huge Power Query fan. It has its place, but if you're going to do enterprise type data ingest, you want to start with notebooks, and you will see that coming up. All right, so the next thing that we had to get to is, we knew we wanted to go with a medallion architecture. We talked a little bit about that to the leadership team, but we really wanted to come up with a little bit more robust vision of what our fabric architecture looks like. And James Sierra, who has the book, since I'm on video and I'm at home, I don't know if it comes across, Deciphering Data Architectures, right? This is an excellent book. This picture, this picture comes from this blog post that if you scan that QR code, or you go to his blog site, his website, jamessierra.com, this came from there. So I'm crediting him with it. I added a couple little modifications to it, but you can see through the steps, right? We want to first ingest the data, and we ingest the data. We're not using a lot of real-time streams. We're talking about a couple of them right now, but for those first 22 data sources, we haven't had a need to do that. There's one that we're trying to finalize up right now. We might be doing that. So we mostly use Spark notebooks to ingest our data. A little bit of pipelines on that. And then this was one of the big this is one of the big additions that I made to this diagram that I don't think is on his, is using mirroring within Fabric. We have still some relational databases that are publish, subscribe. We're the subscriber from our vendor, and that's how we get data from our vendor. So then since that comes into a SQL database, we then mirror that database into Fabric and get a lot of it that way. That has been a lifesaver within our architecture. And just recently, they updated the mirroring technology. You used to have a primary key on the table in order for it to be mirrored. That's no longer a restriction. So that's where we did a lot of our pipelines, is if we couldn't mirror it and it was in a SQL database, we would write a pipeline and bring that in. Now that that restriction within the last month, I think it was, has been taken away, anything that's in a SQL Server data, we're using Azure SQL Server to be clear. Anything that's in an Azure SQL Server database, we're mirroring in, and we get that data immediately. It's a wonderful thing, and that's considered to be within our, we mirror and we consider that part of our bronze raw layer. So the Kevin KP was talking about that restriction is only for Azure SQL DB, not SQL Server. I think you're talking, Kevin, the primary key restriction, which has now gone away. On SQL Server on-prem that's in preview, that you could go through a gateway, they're using change data capture. So as long as your table is supported by change data capture, you could bring it in. But I think, and we could talk at the end, KP, if that's not clear on the comment that you were making. All right,
Yeah,
so
I'm editing the comment right now to clarify that. Thank you for catching that.
Yeah. Okay, so that's part of our bronze layer, but then the rest of bronze is usually brought into us via Spark notebooks. And we end up putting our bronze into a lakehouse. And then we go, there was a lot of discussion around this, and this was part of our proof of concept, is we go lakehouse, and then it's not totally shown here, but we go warehouse into our silver layer, and then warehouse into our gold layer. And there was a major reason for that. And if you ever heard me talk before about how to pick what type of storage you want, lake house, warehouse, for your what your objects in one lake are going to use. The skill sets that you have is probably one of the most important things to do. When we first started going against, we said let's try to go lake house, then warehouse. I think we put together a really good team, but all of them, including myself, we weren't as strong on the Python side as we were on the SQL side. And we had a lot of patterns that people have used at previous companies, that we were able to put in really good patterns in our stored procedures into our silver and gold layer, and that has helped us quite a bit. So that was probably the biggest reason that we picked warehouses in both the silver and the gold layer, and it helped us move tremendously faster. Now we've done a much better job of bringing in the data into the lake house, and we do use this pattern that is here is we bring in the data to a raw area of the lakehouse. So it's a files area. So if we call an API and we get a payload back that's a JSON, we save that JSON as is in the raw area, and then it gets brought into our conformed, gets brought into data lake, into the delta lake, a delta table, to become a conformed parquet file, which is then brought over, enriched into our silver layer, and then it's curated more into our gold layer. And yes, we do have prophecy within our infrastructure. We're using it for a couple things. Um, we're really looking forward to using it for our the best way to term it is item management. We have a lot of things around um, ingredients that go into a salad, and we produce some of them at our own kitchens. We purchase some of these things, and managing all of that and getting everything to get to track down to what is on the line when a salad is produced is a little chaotic and needs to be kind of managed as master data management system. So we're in our final rollout of our milestones to finish up to get off of Tableau by the end of July, and then we will really start focusing more on MDM and conforming the dimensions out of that, or also having stewards, um, data stewards coming in to help us manage what is the right mapping of raw material to the finished product to what actually goes into a salad recipe. So that's all very important as well. We're going to expand into the data science area. Um, we have a couple use cases already in that. We've been thinking on how to do that as we put this whole architecture together so we could still store everything and then share this data and do ML machine learning models with our data scientist. Because again, everything is on one lake. We'll be able to easily share with them. Um, so I do have the possibility of doing data flow Gen 2s here. I grabbed the wrong key, but we have not found any reason that we have to implement them into our architecture. And it would take the team a lot to convince me to put in a data flow Gen 2. So I do say never, but I never say total never because things change. Which brings up the next thing into our relational serving layer. And this kind of works out as its own layer, right? This is not part of our gold layer. The relational servicing layer is just the semantic model. And so just like James pointed out in his stuff, we see doing all of this is our data engineering part of it. Doing the model is separate. And we actually, I'll show how we put that into um, different workspace and everything. Our goal is to have as few semantic models as possible. So we started off with one. And then the rule is convince me why we don't need more, or convince me why we need more than one. Um, so we have a lot of discussions around that. The main reason that we want the one is, again, we're building a bunch of reports off of it. We want all the metrics always to be exactly the same, to always be shared. But also, we're going to do self-service or our version of self-service, which means we will give access to the semantic model and give people build access so that they could use either Excel or their own or Power BI on their own to put reports together. And we want them to come out with the same answers or at least be able to be tracked back, right? So if you start out with, here's what our total sales were for the month, and then they slice it, right? We should be able to get back with the same things over to all of our other reports that's on a consumer's report or a business user producing their own report. We'll get into a little bit later on if they want to add data to it and how they're going to do that, and then how we show whether or not those won't be considered certified or promoted reports because they could do things then to change out what the numbers come out to be by adding their own data into it. But that's the long-term plan. And we'll govern and discover all of this. We are using Purview a little bit. Purview has a lot of different flavors with it, right? You have Purview that's on Fabric by itself. You have Purview that you could use it within Azure. We're doing a little bit of both right now, but we will manage this a little bit closer. We have our eyes on how we're going to use Purview. We do use FUMA, FUAM, which is something that was put out by some Microsoft employees. It's not officially supported by Microsoft, but we use that to monitor our environment and collect data all the time. So I could look at who's doing what, who's using what, and that works as well as with the capacity at the Fabric capacity reports, so we could understand what's going on and how to manage our environment. And that might be something that we might add that maybe I should add down at the bottom here. We do use everything across Azure itself. So Entra for security. We use Azure Key Vaults quite a bit in order to keep all the secrets. We use Azure DevOps. We'll talk a little bit about that and start moving forward from there. All right, so that's a very high level on what our overall architecture looks like. If you're going to put together an architecture, I do suggest you start with what James has put together and read his book. So from there, how do we implement this architecture? And so really the biggest question that came to us was, what is our workspace layout in order to do all of this? And so the darker boxes are our workspaces. And so we have data sources coming into a couple different workspaces. The dotted line one is our domains. And we first started with just one generic domain. And that's what everything started going into. But we knew we were only going to produce another domain when a security requirement came about for that domain. And sure enough, it came up pretty quickly. We started bringing in HR data, and from our HR system, the way it's giving us the data, even though all we needed to do was do some reporting on our hourly employees, both out of our central kitchen and our stores itself, the data that came to us from HR had everybody in it, including salaries. So we wanted to lock that down pretty quick. So really, just the director, myself, and sometimes one other developer has access to that domain. We then clean up that data to take out and only provide what is needed into the main domain, and then we use shortcuts to bring it in from one domain to another domain. Shortcuts are an amazing feature within Fabric, and I'm using them everywhere. These little dotted lines here that you see in this area, those bluish dotted lines show that we're using shortcuts, and we're even using shortcuts across domain workspaces. All right, so we have a data engineering workspace, and we end up with everything that is our bronze, silver, and gold. And that's what each one of these three things represent down here. Let me get back into this mode, right? So this is our bronze area, silver, and gold. Silver came out a little bit funny, right? And I probably should at least put letters up here or something to improve this presentation. So you see, we use notebooks, write everything to a lake house. As I talked about before, then we flow our um, data flows from the lake house over to our warehouse. We use stored procedures to do that and coordinate those stored procedures with data pipelines within the data engineering workspace. And that's kind of important. We'll talk a little bit about why we did some things with data pipelines here, but also you'll see the data pipelines are in this other orchestration workspace. So that's how it moves across this way. I wish I could figure out. I think it's this one. Oh, come on. I can't remember which is the one that has the arrows.
Control
I can't
Shift.
find it. Control Shift. Wow, I got to do both. All right. So everything flows. Oh, the other way. Right. So all the data flows this way. We come into our bronze and end up over in our gold. Now, not all data that lives in silver has to fall into gold. So if we have dimensions that they're perfectly fine within silver, we shortcut those into a lake house within our model workspace just out of silver. Um, and then that way we could reuse it over here in our semantic model. And then our semantic model, all of our reports connect to this one and only semantic model. Again, I say that, but that's our main semantic model. We've hit a condition where we have other reports that are out that are needing a direct query source. And so we have one model for that. And we had to put one other model together because we're refreshing it every half hour. This big model, we don't have to refresh every half hour. So we don't want to run through our big data engineering pipeline for it. Um, and plus it also had a other couple of other things. So I think we're up to, let's see, one, two, three, and I'm adding one more for Zendesk because we're not modifying our Zendesk data yet. So it's like four models, but so they've really been able to convince me to have more. But the key is have single digit, few models as you possibly can, and have the reports share those models. Now, another big thing here is
So
these
Kevin, I don't know if
workspaces. Yeah,
Tim,
I
two
saw it.
questions in the okay,
I'll come back to that in
gotcha.
a second. Because actually we'll talk about capacities in another slide or two, Tim. So we'll I'll get to that. So our we have three workspaces for each one of these. So data engineering, the model, reports all have dev test prod. Our orchestration that I'll talk about in just a second also has dev test prod. Our mirroring, because our data sources, our SQL databases only have a dev and a prod, we just have two workspaces here. Um, and then we end up putting the production data into our test data engineering workspace. So we have a full copy and we could do better report validation out of our test. So we could get into test, validate report functionality and numbers out of test because we have full production data before we have to get it over to prod. But then any one of these that has this symbol, then this is where we're using Azure DevOps, the Git repository. So we hook up a source code repository. Nothing gets into any of these three workspaces without a pull request. And we'll show that process coming up here. But we're coming up, but that means everything is fully trackable from here was the requirement to here's the files that changed within the code, and here's when it went forward. So it's fully trackable from that. And then the other thing is our deployment pipelines. That's kind of what this is representing. We're using deployment pipelines for all three of these to move things from dev, test, and prod. Our orchestration and our mirroring does not have that. The reason we started out is remember with the mirroring, I was saying we had some things that would mirror out of dev, and because they had primary keys in dev, they didn't have it in prod. So this is going to start going away, but I don't know if I'll end up changing this to be within source control and deployment pipelines. I got to test that out. The last to talk about on this slide is our orchestration. So the orchestration coordinates all the notebooks and these pipelines that need to run within the data engineering workspaces. So for example, if we have to run something from the HR domain first, then our next in our other data engineering, this coordinates that across those domains. And it also across the domains, the workspaces, because it could also call to refresh the model. And so this coordination is kept outside. As variable libraries come across, that's a newer feature that was introduced at the last FabCon at the end of March. This will probably move into source control and deployment pipelines as well. All right, a lot of stuff there. I think it's two more slides, Tim, before I get to yours. Um, Let me just jump on that because you put a question out there. Because I don't remember which slide it's coming up. Did we separate it's not a separate subscription, it's not a separate tenant, but we are separating Fabric capacities. And just like everybody else in the world, we're using as much trial capacity as possible in order to keep our costs down. But trial capacities are expiring now. One of the things that we did is we restricted the developers on who could start trial capacities so that we wouldn't get into an overall thing that we couldn't start a new trial. Then all of a sudden, my capacity that we've been using for months now won't renew. So somebody else was able to start a new trial capacity. We only use that for dev and test. Our production is then put on to paid capacities. And as we're not allowed to use trial capacities anymore, then we'll pay for other capacities for the lower environments. So yes, once we get to that point, I would separate out my capacities for the lower environments and the upper environments. And even in prod, we're using two separate capacities, one for data engineering and one for the semantic model and reports. This way we could see the work that's going on there. And as we onboard people to do self-service against the model, if they do a whole lot of work that all of a sudden freezes up that capacity, it doesn't impact our data engineering. So yes, capacity planning and buying multiple capacities is things that you have to think about. So, and we could get deeper into that conversation later if we want. All right. I've talked a couple times about project and code management, and I do see we are definitely going after way after 7 o'clock on this. So I'm here as long as you guys want to talk. So or hear me talk. So one of the things that I really wanted to implement, and I had it written down when I first started talking with this company, is this is a must-have, and it was something that was brought up early on because they weren't using source code. And it was like, if you want me to come in as the architect, that's a no-brainer. Everything is going to be in source control. And when I say everything, I mean everything. If there's something we can't put into source control, we're probably going to make an intentional decision not to use it because everything that we need can be put into source control. And then we wanted to link all of our work items to the source control changes. One of the things you heard, I talked earlier about, we were standardizing on tools. And we weren't using GitHub, but we already had Azure DevOps in play for the little bit of source control that they were doing. So we wanted to stick with Azure DevOps, but the corporation did make one little pivot here, is they decided because of the way other groups are using Jira and the way we could integrate with those other groups, they wanted to use Jira for the work management side of it rather than the Azure DevOps. But these type of things you could do on either side. We learned a lot in other projects, other places that I've worked on using Azure DevOps, producing our work management there, doing our stories, our tasks, our features, right? And then tying those to branches and code changes and pull requests on the GitHub repository. So we looked for a way to do that. And what we found was Jira has put out by the Jira company itself an add-on to Jira that is for connecting to Azure DevOps. And that's what I'm trying to show with the black bottom part here. This represents, I keep hitting the wrong button. This represents a user story, a story level in Jira. And you notice what we have is this tag. And so every time that we produce a branch in Azure DevOps, the branch has to start with the tag of that user story. And then when we do a pull request, we put in the name of that pull request at the very beginning, the tag of this user story. That produces this connection. That Jira add-on goes and looks at what's going on in Azure DevOps and then connects the two. So we could see that this got done because there is a completed pull request. And then if we needed to, we could track back to that pull request from this user story or by the tag itself of what we see over in Azure DevOps. And then we could see all the commits, all the changes, everything that changed because of this one user story. And then using the rest of Jira's process, when we do our deployments forward, which gets us back into the right side of this presentation, we tie it to a release, and we have release tagging in the Jira stories, and we have release tagging that we know of through our Fabric deployment pipelines. And so we could tell when everything, after it got done in development and moved in, we could tell when it got deployed to test and when it got deployed to production. And again, we're triggering, this is a manual trigger today. We're looking at using Azure DevOps APIs to trigger things off, but we're currently using Fabric deployment pipelines to move through dev, test, and prod. The other thing that we're doing is if you search CI/CD workflow options in Fabric, there is a article out there, and once I kind of escape out, I'll try to put this link in here. And this talks about how to do, I think it had like 3 options in there, and we're using option number 3 to where we have our main branch is connected to our dev workspace. And then whenever a developer starts a new feature, and we call the feature that this user story that I have tagged here, they produce their branch. That branch gets named with that tag. And then that gets synchronized to a feature workspace up on the Fabric service. And once they synchronize, now they have all the code objects that they could work and change and commit into their branch independently in their own workspace. One of the newer things that just came out is the ability to synchronize to an existing workspace. So each developer has their own feature workspace. They produce a new branch. They just connect that new branch to their feature workspace. Everything gets updated to what the latest is of that dev. All the objects, all the code objects, they have to reset up any of their data, or if their data remains out there, they could use that data. So so this way they have a very much isolated environment for everything that they need, right? Including their own data warehouses, everything. So they're not impacting anything. Once they keep doing their commits, the last thing that they do is their pull request to do the merge, and it merges it into that main branch. It gets sync, puts it up into our dev workspace, and then we run our dev workspace on different schedules to keep testing things out to make sure things work. This process has worked very, very well for us. There are some gotchas on some things we'll talk about here as we get a next level deeper. But for the most part, it works. There's been times that Microsoft has made changes and it's kind of messed us up, but that is what it is. Let me grab this link. Where's that going to go? Okay, good. It went over here. So if you want to look closer at what we have there, there's that link, which is the advantage of giving this online. All right. So we talked about the different workspaces that we have, and this is a little sample of what our data engineering workspace looks like. So you see, we just named this one SAG Fabric, and I put in blocks that this is our dev workspace. It's tied to our deployment pipeline and a development method. You can see when I took the snapshot, it was definitely using the trial. That's what this little icon was using. And the first thing I do is I set up folders for my bronze, silver, and gold layers. What I've seen that I think would be a little bit better that people have done is they number these as well. Um, and I wish I would have seen that ahead of time. So that's a good way to organize your workspace. We also have a data warehouse that we call our ETL control data. This is any bit of control data that we as developers have to add to our environment. And we separate that out to one and only one database. This way, we're never saying, oh, we got to add that to the gold to the gold database or the gold data warehouse or the silver data warehouse. We have one place that we add it to, and we know all of that data is maintained by, we use shared queries, and we have to run the shared queries. We know that's how that data is fully maintained within that data warehouse. Um, Okay, so starting from the bronze, right? One of the things that we found as a trick is if you start taking education from about fabric, the first thing they show you in notebooks and your bronze lakehouse is to attach it to your notebook and make it your default. And I'm here to tell you, you can do that, but it makes it difficult to do deployment. So we set up this set of code and we mount the bronze lake house within our code itself. So we do not have a default lake house. That hurts us a little bit and be able to do Spark SQL, but you can do it if you absolutely have to. We end up using a lot of the Python, the PySpark, or sometimes go out to pandas type setup. So everything you could do in Spark SQL, you could do in Python or PySpark. So we do everything within that. This sets up a couple environment variables that we use throughout the rest of this code. And since we want this code everywhere, we put it into a common function notebook. So we have one notebook that is all of our common functions, and at the top of our other notebook, we run that. And then this code gets executed from that. So that's how we always make sure the same lake house is mounted. Now, the other thing that does is remember what I just showed you, how we have feature workspaces for each one of our developers. When a developer runs a notebook in their workspace, it mounts that lake house from their workspace. The attaching of a lake house to say that's in our dev workspace, if we branch out, that would connection would remain, and we'd have people trying to change our dev workspace data all the time. So by doing this, we not only allow our deployment pipeline to work better because we don't have to try to change out that default, but we don't need the developers to remember to change what the default is, and they always connect to what's in their workspace. We do the same concept that's in the middle of the screen here for running our stored procedures. So again, we're using a lot of stored procedures to get to our silver and our gold. It's because that's what a lot of our skill sets fell into. And so the first thing that we do is we find what data warehouses exist in the workspace by doing an Fabric API call. We iterate through that and we look for this case, it's looking for the silver workspace or the silver data warehouse. Once it finds it, it sets it into an environment variable. And then that environment variable, as you see, is picked up. There's one that's picked up here, and there's one that's picked up here. So then this stored procedure, this SQL, is actually run based upon the connection that this finds. So again, within our developer feature workspaces, it's an isolated
Kevin,
environment.
Can you repeat that? You said it's actually run, and then you cut off the rest of the sentence. You said this stored
I'm sorry.
procedure is actually run.
Within the correct silver data warehouse.
Okay.
So it's run within the one that the variables were set from this first part of the code. So that's where when it's run within our developers feature workspace, it finds the data warehouse for silver in their workspace. When it runs in dev, it finds the data warehouse in dev. When we deploy to the next environment, without having to change anything, um, the code automatically finds the warehouse that it needs within its workspace. So this is a very dynamic way of doing things. Variable libraries are going to change some of that, but I'd probably still keep this in play because it's a whole lot easier than trying to have to remember to change variable libraries. But I got to play with those a little bit and to really kind of find out. And then just like this is looking at what our survey data is. Um, so it only needed 2 dimensions put together. Now I probably orchestrate another bigger dimension before this, but it only had 2 other dimensions to have to put together before fact survey to put together. So I put these little pipelines together to control a process and then orchestrate the bigger process in the other orchestration workspace.
Kevin, one quick note. With
Mhm.
variable libraries, you're still required to create a local variable and then map that local variable to the variable library.
Yeah, I haven't played with them, so thanks, Kevin, for coming out with that. What I'm still a little bit worried about is that they talk about it being dev test prod, which makes sense, but how am I going to get the right variable in there for the unique workspace for every feature developers for every developer's workspace, which is why I think this lives. So um, I'm hoping to use it for some other things, but I may not use it for this part because I don't know how to solve that problem yet. But that's future Kevin problem. All right. So after we build out do all our data engineering work, um, we got to get on to our modeling work. And as I mentioned earlier, we use shortcuts to go from the DE workspace, either the silver or the gold, into a lake house that lives in the model workspace. So that's this lake house here. And this workspace has changed quite a bit since I added a couple more models. I used folders to separate out the models. Today I decided to use a new lake house for another model that is hopefully just temporary, but we need it there. The other thing I do is I put together a data dictionary report for the model, and I use this method. This is something that Kratos, Chris Wagner, and a couple of others we've all come up with. I think Chris still has it on his website. We connect this data dictionary to this model by a parameter, and then all I got to do to update the data dictionary every time I change it is refresh this semantic model, and this report comes up to date. And then the report developers look at that in order to understand what is in the model itself. I've also started building confluence documentation on the model, which seems to be a little bit easier. Since I use tabular editor, I have scripts that generate markup language to produce that, but that's probably a whole different presentation. So of documenting a model. So um, okay, so yeah, and then also since I use tabular editor, I have scripts built out for the time intelligence and growth. And then we're using DirectLake to reduce the refresh times. So whenever you do have to refresh the model, it takes seconds rather than minutes, even though we have millions. As you see at the bottom, that one of our largest tables when I measured it a while ago was at 97 million rows. I'm sure it's up over 100 million rows. And just to be a little bit transparent on that, what's in our silver for what's feeding that largest table, I think is 600 million rows. Um, and that's kind of important because I think I meant to bring this up earlier. So we start out with bringing in like 600 million rows for one of our like for sales down to our item level and a lot more things about that item. And then we reduce it down to 97 million rows into our largest table that ends up in the model. All of that can be done um, if we build out that I start with no data in there and I want to get to building all that up, the speed that I've been able to get to is about 10 minutes in doing that. So we're running anywhere from 10 to 20 minutes for our whole cycle to go through to update everything for our daily sales report that I was talking about taking hours in the previous architecture. A lot of that is because Fabric itself will scale up for us as it needs to. And as that data grows, right, it will just scale out. I don't have to do anything extra. But it's also the architectural approach that we put together in order to bring everything up very quickly. And because we're using Direct Lake, the last part, right, we're not having to, this happens a lot with Tableau, is you even if you build out a table, say in your SQL database, and a lot of people use Tableau Online, that Tableau Online may have to upload that data set, kind of its own import into the cloud. So, so there's a lot of different timing factors there. To kind of finish out this slide, we have currently 20 fact tables. I may have added a couple more, and 26 dimensions. So you could tell I'm really reusing dimensions quite a bit. And as we go through a lot of design sessions, so much more that we're kind of reevaluating because we're on calls so much, going through designs and talking people through what they need to be doing. That's very useful. But if we have a lot of people on the call, it takes people away from doing their work. So we're constantly trying to rebalance how we do our team and our team meetings because all of us work remote. We got some people in Phoenix, a lot of people here in Dallas, but um, we do spend a lot of time on meetings and make sure everybody's got things right. Currently, there's around 1,600 measures. And again, that has to do with our time intelligence measures. And this is why I have it scripted out because we're preparing for self-service. So what I have found is if people want year to date, prior year to date, variances, this, that, the other. I tried a couple years ago rolling out a self-service model, doing that with a calculation group and found that the end users weren't sophisticated enough to use that calculation group. And sometimes they wanted to do it within something that they're mixing a lot of things within one visual, and the calculation group would apply to the entire visual. So because we have scripts and we could script out everything, we add all these measures into our model whether we're currently using them or not. And that sets up for the self-service coming up. And I had somebody ask me about that. Says, well, if you add all those measures to your model, doesn't that slow you down? And it's like, no, it doesn't slow me down because if the measure is not used, it doesn't slow anything down, right? It doesn't matter if I have one measure or 1,000 measures. As long as I'm only using that one, that's the only one I ever looked at. So now, the only way measures slow you down is if you write them incorrectly. And one of the things that I did in order to help make sure I wasn't going to write them incorrectly is I used SQL BI's free tool called Bravo, um, modeled out the measures that I want with the growth and the time intelligence. They generated code that I really trust, being SQL BI and the Italians, some of the best people knowing DAX out in the field, and then took their stuff and made it into my templates. So it's a good shortcut to kind of build out your time intelligence type of work. All right, so all of this, and now start talking about the reports, right? So you see, this is a ton of work, and this is where I was trying to kind of emphasize. If you're going to move from Tableau to Power BI, you got to put in the back end work because you want to get to this thing. And I'm sorry, Donald had to drop off because this is the slide that he wanted to see. This nice star schema, in this case, looking at labor. Everything that I talked about, where I think I said I had 20 fact tables, I have this type of structure on every fact table. This is my star schema, my dimensions going into my facts in the middle, dates coming into pretty much everything. Store is going into a lot of them. We tend to break out our reports by either our store or our central kitchen. Obviously, stores are most of them. So that dimensions reuse pretty much on almost all the facts that are, except for the ones that are central kitchen. Um, so this kind of gives you an idea of what the report looks like. Obviously, I had to blur out the numbers. This is a report that they wanted to have emailed out, and it looks almost exactly as the Tableau report. And I was kind of resistant of doing this at first because I really just wanted to get them online. But this turned out to have a lot of value in it. By reproducing that report, we cleaned it up a little bit. than what the Tableau side looked like. In fact, we got comments that this looked a whole lot cleaner. But the basic structure of what's going on down here, every one of these is a measure. And then it's put across, this is a rolling 7 day time. So it's every day for 7 days. This is the week to date, and this is our variance of those days and a week to date variance. And then so it shows all of these measures, and this builds out relatively fast. Um, so we actually build it in the background and email it out as a subscription. But even if I go look at it online, I'm not, it only takes a couple of seconds for it to render for me. Except for since it's direct lake, if data got swapped out, obviously that's got to happen first, but usually I look at it pretty close to the time that we've sent things out. It's extremely fast, works great. Now, so all of these reports are thin reports, and we set up a template. So all the color coding that you're seeing here is all within our template file. And obviously you could do that with Tableau as well. So make sure you do that with Power BI. Move it over. We happen to use Power BI Tips, their theme generator. They have a really good one, so I'd recommend looking at that. There's other ones out there, but help use a tool that could help you produce your theme and apply your theme, store it into a Power BI template file. And so our process is everybody that produces a new report starts from the template, makes their updates. The template is connected to the one and only data set. So obviously, if there's the other data sets, we have templates for those, but this is where we were at for the longest time. And then the report developers are not allowed to use report level measures except for things that they have formatting. So for example, on this report, this date is a report level measure in order to get this proper formatting here. So this way they see it exactly the way that they want it. I didn't have to build a special measure within the report because not a lot of other reports do the report this way. Even if you did it, you would have to do the selected measure type of thing. So it made more sense in order to build it as a report level measure. On this report, there's not other things, but there's some more where we put titles in. Those titles would be those type of report level measures. I actually, when a pull request comes in with a report, because yes, we do use source control, branches, and pull request for reports to come over. And it did take my report developers a little bit longer to understand that process than, say, some of our data engineering developers, because a lot of the data engineers were closer to using source control before. But this was kind of new to a lot of the other report developers. Once they got the hang of it, that we have short-lived branches and they do pull requests as quickly as possible, a lot of their problems went away. And then once that pull request comes in, I have a GitHub Copilot script that I could run. I could open up the report JSON, ask Copilot to go through and find my report level measures and check to make sure that they are only measures that are done in formatting. If I find other measures, then I could decline that pull request and tell them to take it out before that gets in. So that's kind of one of the nice things. And as we move to the enhanced report format, I suspect that will get easier if you know type of thing. I'm going to try to go through a little bit quickly because we're like way into this, right? So deployments, we use deployment pipelines. As I mentioned, we've had dev, test, and prod. We haven't seen a need to move in more things. So, like right when I took this picture, you could see that test uh, had 20 different changes, right? There's 20 changes in development that aren't in test, and there was 2 changes that were in test that weren't in prod for whatever reason. Maybe I was testing something, but when I actually do a deployment, I would expect that this would come out to either the same 2, because sometimes I put objects inside my test environment for backups that aren't over here. But having this count and keeping track of the history, having things that I could tag to know exactly what the deployment was and why, works out really well by having all of this. Um, the the data engineering, which is what this is showing, has one release cadence. We do that monthly, but we could do our reports depending on how fast the report developers are, and if everything that they need is in the semantic model that's already up in production. We could do report changes for a while. We were doing them almost daily, right? So we have a different deployment cadence for our reports, our semantic model, and our data engineering. Data engineering being once a month. Model goes at the same time. Actually, once a month, all three go at the same time. But if we have the data engineering information or we just need to make measure changes in the model could go more often, and then the reports go as often as we need. I know Tim left, but this is where I was laying out what our capacities are. Maybe I need to back that up somewhere in this presentation because the earlier point is a lot of people were asking that question. We are currently using two F-16 capacities. So we allocated enough budget to look at an F-64. I've always talked about we're going to separate that out into multiple capacities. We're looking we started off really with an F8 and we had everything on the F8 and then all of our report subscriptions overloaded it and we got locked out of the capacity. So on that day, which was actually Good Friday, a day off, I rebalanced everything. I moved up the F8 to an F-16, went to reserve capacity so that we saved money, and then put another F-16 in. So we have our data engineering on one F-16 and our reports and semantic model on another F-16. We're spiking when we generate all the reports that we send out, but it's not throttling us in doing that. So we could spike and not throttle. And then the capacity itself is still is well below 50%. So we see that growing before we have to jump up to a whole nother level, which will allow us, once trials go away, to use either an F-16 or an F-32 for our development environments, development test. The orchestration, again, are pipelines, and this is what coordinates everything across the workspaces. So this is an example, and all of this flows from left to right. So I could run a notebook that's bringing in the information for our stores, and at the same time, I'm running a notebook that is our HR to get the demographics. These two things live in different domains. They run all at the same time. These sync ones are the lake house has a metadata refresh slowness sometimes, so I throw in sync processes and then run our notebooks. I decided to run these in order. I could probably get a little bit more speed out of it if I make these all run at the same time because there's really no dependency on them. But I was doing that in order to avoid hitting queuing or other type of problems. But at the same time, you could see I could invoke, instead of a notebook, I'm invoking my dimension build. So at least while these three things are running, I'm running this other part, synchronize everything. Then I start doing everything for silver, everything for gold. And then my last step, I refresh there's a sync for the model lakehouse and then the semantic model. Again, this whole process similar process took hours over in the old architecture. 15, 20 minutes is what it's taken us to do consistently. Because the other thing that we do is we could rebuild everything within that time. And we refresh things for the last 30 days. So we don't expect this time to go up. We have things configurable. So we only incrementally load through our whole process what we need. Adoption and self-service. So again, we were talking about self-service earlier. Um, we did a lot to where we produced that report that I showed you so that it would look almost exactly like the Tableau report, all the values that were on there, and then we had them up side by side comparing values to show that our numbers were the same as the other ones. In cases, what we found is there was mistakes over on the Tableau side and the values weren't correct. We ended up able to explain why they were incorrect. And then we're going to be looking at using role-based security. So I'll probably implement our role-based security using RLS in the semantic model. That's what I trust the most at this point. And I think somebody mentioned RLS earlier, that a comment that went by real quick on me. But yeah, I'll implement row level security in the model. I'll be looking at how that's going to work as the one security in OneLake. But we may look at the one security in OneLake for how we are able to serve out data in a self-service to where we share data over to somebody in their own workspace for them to either add stuff on or do their own data science from there. I thought I had something fancy for questions, but I don't. So that kind of wraps up the presentation. Man, I went long. It's great. I see a couple comments. Thanks for telling me that's a good presentation. Any questions? Fernando just coming back in. Hey, Fernando, we're just wrapping up.
I knew it. Anyway, I watched the recording.
Okay. Before I stop the recording, any questions that people want to ask that they feel would be good to get on the recording?
How much data are you loading nightly?
Nightly, we go back 30 days. So this way, if something comes in from our vendors that wasn't there before, we're able to reprocess it. But I don't remember the row counts off the top of my head. It's probably 1 million or less that's on a daily basis. But then it adds all up to that in the final gold layer, the 97 million. On the previous slide before project and code management, you mentioned a new thing that was introduced. What was that feature? Let me get back to the presentation and see if I can find that slide. It was either, I think the couple things I've talked about was
I think it might have been branching out to existing workspaces, Kevin.
yeah, where was that? This. So project and code management. What we used to have to do here is when we produced a branch, we had to produce a new workspace. And every time that we produced that, it put a lot of noise. So the new feature of branching to an existing workspace is what allowed us to give one workspace per developer. And then this way, we always know when we're looking at that developer's code, what workspace to go to. It's less workspace management. The one before this slide, which was here. Here, I talked a little bit about the new features of mirroring, allowing that you don't have to have a primary key. On orchestration, I don't have the orchestration going into deployment pipelines because it really kind of hard codes everything. The variable libraries is something I'll be looking at here. You heard us talk a little bit more about variable libraries, but I think an orchestration is going to work out pretty well. This allows me to set up in pipelines specifically in other areas, is I could have values in this variable library and say, when you're in dev, you use this set of values. When you're in test, you use this set. So like I could say the workspace that you're connecting to, and I could give a different workspace GUID for each environment, or the lakehouse GUID that you're connecting to, and things like that. So I think that's what I was talking about there. So I hopefully that answers your question. Let's see what else is on here. How do you avoid the problem of inaccurate data getting into your system? Human errors, was that a big problem? So human errors are a big problem in some of our tables, especially for data that we bring in, say through spreadsheets. So we have a lot of data that is, the I'll give one that, for example, is our finance people want to give a forecast and they give us a spreadsheet, and that spreadsheet consistently changes. So we're looking at, we looked a little bit of using prophecy for something like that to try to make sure that it's reference data. I wouldn't call that master. We're looking into SharePoint list. We're trying to find ways to solve that. But what we have right now in a lot of our code is this is the other nice thing about data warehouses is I could start a transaction and I could do multiple SQL statements within a transaction. So we have a process to we first build out a kind of almost a temp table, but we store it into a schema that we call ETL stage. And we say, here's the data that we're going to process for this run, and it gets put out there. And then we open up a transaction and say for our store dimension, right? We'll say, here's the data that we need to use to update our store dimension. We'll put that into this stage table and then start doing, inserts, updates, whatever we need to do for that. And then the last thing we do is we run some queries that we have that say, like, we know we never want to have a store row for a store number in there active more than once. So we have a query that checks for that. We check to make sure a couple other things that are in there. If any of those statements fail, it throws an exception, and that's all within the transaction. So what happens is that data gets rolled back. So our data still remains the same, even if we have to refresh the model for something else. So the use of transactions within stored procedures is what helps us with that. And then we build in data quality checks within those transactions and throw errors for that. Now we had another one that we did have a data quality check, and we we were throwing the error on it, and somebody messed up in a table in the source system that they needed to put something in, and it stopped the rest of our processing, and we didn't like that. So we put the data quality check earlier, and we log it because we also have a logging table besides throwing exceptions. We log all of that. If you're doing things in notebooks, you could use Great Expectations. I'm doing things in stored procedures. So that's what's in the chat right now for anybody watching this without the chat. We'll talk about that here in a second, Kevin. But anyways, I moved that data quality check up, and because I put things into a stage table, I could check that stage. Actually, I think, what did I do? I now maybe built it into a temp table or something, and I could check it. And if it doesn't meet what I need it to be, is I revert back and I don't change my stage table, and then everything moves forward. So I don't use this was something that we were mapping categories on, and we said it's okay to use yesterday's data if the quality for today's data doesn't check. But yeah, you got to build a lot of your stuff in the chat. KP referenced a Python library called Great Expectations. If you're doing this in lakehouses and you're doing this within Python notebooks, that is a great way to check your data. Or if you want it, if you're saying that you could put the data out and then check it later, even into a warehouse, we decided to take the approach of, if we notice anything that we don't like, we do a rollback, and then we stop the process. So anything else, and then I'll stop the recording. Wish you could download my knowledge and all the work you've done here. Well, you can reference it because we'll have it up on YouTube, and you know, um,
Kevin, there's a question about your team sizes and user base size.
oh, thank you. Yes, I did see that, and I scrolled by it. So on our team, we have, and we've balanced it out a little bit. The team is responsible for not only business intelligence, but data integration to other systems. We have two guys that pretty much focus on that, and then when they have time, they come over and help us on the Fabric side, and we use them quite heavily in the beginning to get everything rolling. And then we have two other dedicated data engineers. So our data engineering team is about the biggest. So let's say we get half of those other two guys, so that's 2.5 people. The equivalent of 2.5 people on the data engineering side. The semantic model is something that I do on my own. I do a little bit of the data engineering, mostly silver to gold, because then I could do that at the same time I'm doing the model. And then the reports, we have a team that's offshore that keeps bubbling up and bubbling down. So I think that's two or three people, and then one dedicated here onshore for our report development. And yeah, so so all of that combined, what did I just say? Maybe that was 5 to 7 people, which is about a good team size. Our user base, most of our users today are consuming those PDF reports that we email out. Um, Once we roll off of Tableau, which our license expires at the end of July. So during this month and next month, we will be onboarding people, our finance people first. So we expect to onboard uh, 5 to 10. So it's going to be kind of small at first, but it's going to grow to be whoever in the company. So that's going to continue to grow as we do other things. And then some of those people will get access to the actual SQL tables, um, either through a lake house or whatever. And then so this kind of rolls into in the final solution, can we export to Excel? So, oh, that's Fernando being a little bit joking, but yes, um, we actually think about all the reports that we put together, if we want them to export things or not, and we turn the icons off, we turn the options off on the visuals on an as-needed basis if we think they need to export to Excel. But we're going to try to keep away from that by saying, if you actually need data, let's onboard you to a workspace that we give you that data inside Fabric and teach them how to either write SQL or do something else across that. Um, is there an overall advantage of using Power BI versus Tableau, or they give the same visualization results? So the way that the team that put together the Tableau reports, um, I would say what we're doing right now gives the same visualization results. There's a lot of opinions out in the marketplace or out in the community that Tableau has better visualizations than Power BI. I don't agree with that because I've seen a lot of poorly visualized Tableau reports. I've seen beautiful Tableau reports. I've seen a lot of bad visualization Power BI reports. I've put together bad visualization Power BI reports. But you get somebody like Reed Havens or whatever, and he makes beautiful Power BI reports. So, or you get into the ones like Carrie Kalowski, who does great with Deneb, and other people with that. They put together beautiful reports that I don't know that you could put together in Tableau. So it's again, I think the core visuals in both, you could do pretty much the same things. It's how you learn to go to the next level from there on how beautiful your visualizations are going to be. But the beautiful is to me secondary than are you leading somebody and are you giving them the right data to make the right business decisions? So and I'll stop it at that.
Yeah, Kevin, this is
Yeah.
Don. Thank you very much for the great presentation. Um, in the Power BI world, you typically do this type of star schema, and then you build your relationship and then your semantic model. And the Tableau world, you like typically most people put together a big gigantic table. But
Mhm.
all the Power BI stuff you've been doing, are there use cases? Or have you run into use case that are easier just to build one table instead of separate, the data into multiple tables and build a relationship and so on and so forth? Because depends on the use case. Some data are so messy and it takes a huge amount of effort just to model it. For Power BI to consume, might be just easier just build a big table just for the whatever Power BI to consume.
Yeah. So could you do it? Yes. Will it scale? Definitely not.
No,
Right.
probably not.
So
Yeah.
yeah. So I mean, I was doing something for somebody the other day, and I was just exploring the data, and I built one big table and brought it into Power BI to explore the data and to look at it. when I put the final solution together that went into the semantic model, I broke that out into a true star
Okay.
schema. Okay. But I tend to think in star schemas. I start from star schemas 100% of the time. Right. Or I say that, I guess it's 99% of the time because I started with what I wanted for the star schema, but I wanted to look at this real quick and I wanted to give them a little bit of feedback just on this area and say, what do you think of this? And so I just put one big table together. But it was a couple hundred rows, right? It was looking at 1 month or 2 months just in order to start kind of thinking about, is this the type of reporting that we need? And then invest the time to go do the proper star schema. Because if you don't, Power BI won't scale. And you got, at that point, you got a choice, right? You either
Yeah.
refactor or add more capacity for it to handle everything.
Yeah, I
So,
think I like that idea. Just to do a big table, just to explore, to make sure. If it's just one-off stuff, maybe just one big
mhm.
table is fine. But if it's continue to be used by a lot of users, it's worth time investing the time to break down into a entity relationship and step
Yeah.
schema. Yeah, it's
Yeah,
definitely. Thank you, thank you.
and I have done it before to where I was pressured by the client to I would put it in, with can we just do this and show me something quickly? And I would get them to actually write down that part of the requirement is this will be used by no more than 5 people or X, whatever that X was,
Yeah.
right? 5 to 10 people. And I'd get that documented. And then when all of a sudden they keep adding people to it or ask me to add people to it, that I would say, now's the time you got to come back and reinvest this. You can't go over what you agreed to. And of course, they're the client if they really wanted to. But this way I had everything backed up that going, when they go, well, now this is all of a sudden slow, or I added, we added more things. This was beyond the scope of why we did the one big table. And so what I've found is, you know, it's usually worth my investment or pushing the investment to put it into the star schema ahead of time because
Mm.
from the skill sets that I have, I could tend to do it very quickly, right? And so by putting it out very quickly, I could grow it that way, and I usually have it better. The times that I've had to push it out, or that they got a different consultant to push it out, they usually have run into problems and try to rewrite it later on. So, and that's within a span of, say, me being with this client and other consultants there. Within 6 months to a year, I could see them that they were forced to rewrite something that I warned them on. So.
Thank you.
Mhm. All right. With that, I'm going to go ahead and stop the recording.